away from the graphing. There are still some tidbits of graphs that we'll still work with, but now we're going to shift our focus to solving a quadratic equation. So, as you can see on the diagram, there are 4 different ways to solve a quadratic equation. Unless the problem specifically tells you to solve it a particular way, then I don't care which way you solve it. So if you're a person that is very good with factoring and quadratic formula, then use those two to your heart's content. I'm not going to tell you which one to use unless the problem specifically tells you. So each method requires its own set of rules. Keep in mind, in the first unit of the school year, we did a study of square roots, simplifying square roots, and factoring. So we are going to still be simplifying square roots and factoring. What I will do is repost the notes from simplifying square roots and from the methods of factoring, but do not expect that we're going to devote a whole day to reviewing those 2 things, because we've already done that. If you need review on how to simplify a square root or how to factor, we got after school tutoring, in which we can do as many examples as we feel you need. So, solving equations with square roots, that's where we're going to start. So, when you are solving an equation using square roots, you either have a variable squared equal to a number, or some quantity squared equal to a number. Those are the general setups that the problem would take and lends itself to square roots. So the first 2 problems are fairly garden variety generic problems. Y squared equals 64. So again, fairly generic. There's nothing in front of y squared and there's nothing behind it. So you can go right ahead and take the square root. A square and a square root are opposites. They drop out. The square root of 64 is 8. However, there is another way to still get 64, and that's using negative 8. 8 to the second power gives you 64. Negative 8 to the second power gives you 64. So since both of those numbers work, you are required to get your answer as y equals plus or minus 8. So if you leave off plus or minus, it is wrong, because you didn't get both of them. Since some of your quizzes and tests are computerized, on a computer, the easiest way to represent plus or minus is to put plus, slash, minus, and then the number 8. That's pretty much how you would put it in if it's on a computer. Plus, slash, minus. So I make sure to say that knowing that on your quiz is computerized. So problem 1 is your garden variety, fairly simple square root problem. Problem 2, 2x squared minus 7 equals 33. So you have x squared But now you got something in front of it, and you got something behind it. So we have to take care of that before we start taking the square root. So the minus 7 has to go. And the 2 has to go. So you cannot take the square root until the square term is isolated, meaning it's by itself. But now we can take the square root. Square and the square root drops out, so that's x equals plus or minus. So 20 is a problem. That's not a perfect square. Don't fall for the trap. If you put 4.47, go ahead and mark the problem wrong yourself. You're not allowed to give the decimal answer unless it's a word problem. So we're going to break down the square root. 20 breaks up into 4 and 5. Square root of 4 is 2. Square root of 5 you can't break down. That's your final answer. Again, if the square root is not perfect, then you need to break down the square root. Do not give the decimal answer unless you want to mark it wrong yourself. Questions, problems 1 and 2. Alright, I'm saying you're hearing me, so let's go to example 3. So, example 3. Same rules apply. 9z squared minus 4 equals 12. So we have z squared, we need it by itself. So minus 4 has to go. 9 equals 16. And then the 9 has to go. 16 over 9. So now z squared is by itself. So we can take the square root. So z is equal to plus or minus. So you have the square root of a fraction. So if you have the square root of a fraction, you can break it apart. Square root of 16 is 4. Square root of 9 is 3. And that's it for example 3. Any questions on 3 before we do 4? Very well. Problem 4. The problem 4 Now you have a parentheses squared equal to 27. So remember, to use square roots, you either need the variable squared or you need the parentheses squared. So here's what you don't do. And I'm going to put it in red so that you know for this particular problem, this is what you don't do. This is not a situation in which you're going to write it twice and work it out that way. That's not that type of part. For this problem, since there is nothing in front of the parentheses, and there's nothing behind the parentheses, you can go right ahead and take the square root. So for some of you, this is going to require you to do a little thing called slowing down and looking at the problem. Slow down, the problem. Figure out what's going on first. Now we can go ahead and solve it. Square and the square root drops out. That's w minus 6 equals 27 is not a perfect square. So you got to find two numbers that multiply to 27, one of them being a perfect square. Square root of 9 is 3. 3 stays underneath. So that's plus or minus 3 square root of 3. Any questions before we finish the equation? Well, still got to get w by itself. Still got minus 6 sitting over there. So you have to add 6 to both sides. So when you write this final answer, the correct way to write the answer is 6 plus or minus 3 square root of 3. However, I'm not going to penalize it if you wrote it that way. You just have to make absolutely certain that that plus or minus stays in front of the number you took the square root of. So with the parentheses there, it's not a harder problem, just a couple more things you gotta pay attention to. Any questions before we continue? So that's square roots. That's a nice, quick overview of square roots. And the main thing here for some of you will be reviewing how to break down square roots, which I'll post the old notes of what we did for square roots. Now let's factor. So in the beginning, in the prerequisite unit, we reviewed all the methods of factoring. Now we're going to actually solve equations by factoring. Solve equations by factoring, we need what's called the zero product property. So zero product property basically means if you have two factors set equal to zero, as long as they're equal to zero, then you can take each factor, set it equal to zero, and solve it out. So, if you have an equation that's already factored, and it's equal to zero, then you can separate it into mini equations. That's basically what that allows you to do. So, case in point, example number 1. X minus 6 times 3x plus 1 equals 0. It's already factored. It's set equal to 0. So you can separate it into its mini equations. And then solve the mini equations. So x minus 6 equals 0, x equals 6, 3x plus 1 equals 0, so 3x equals negative 1, x equals negative 1/3. There are your two answers. So if the problem is already factored, then you can go right on in, separate the problem, solve the problem. Of course, it would be very, very beautiful if every single problem was already factored, separated, and be done. You know, good and well, that's not going to happen all the time. So, let's start factoring. The other two examples up there, just for those who are going to work faster than me. They got it like that. So, just to remind you about factoring. The first rule of all factoring is greatest common factor. That's the first step for all factoring. Then, what you do after that depends on how many terms you have. 2 terms, 3 terms, 4 terms. Depends on what you have left over. If you have 2 terms, then it's difference of 2 squares, sum of cubes, difference of cubes. If you have 3 terms, then that's MAF. 4 terms is grouping. So again, all this was done in the prerequisite unit, which I will post those notes again in case you need to refresh yourself. So, in the case of example 2, 3x squared plus 9x equals 0. It's equal to 0, so we're good to go. We've got a factor, 3x squared plus 9x, which we can do that because we can take out 3x. So if you take out 3x, you're left with x plus 3. That's not going to factor anymore, so you can separate it. Questions 1 and 2. How come you can't just disregard it?
Oh, like how come like oh wait, never mind. Never mind.
Wah, wah, wah. It's all good. Any other questions? 1 and 2. All right. Example 2. Example 3. So example 3, we introduce something new. And that is the equation is not equal to 0. So if the equation is not equal to 0, you better get it equal to 0 before you start trying to factor it. So this has to equal 0. So we're going to take 13, subtract it, and move it to the other side. So, if you don't do that to start the problem, number one, good luck trying to find anything that multiplies to 85 and adds up to negative 17. And two, just go ahead and mark the problem wrong. Once the equation is equal to 0, though, you can go ahead and factor it. There is no greatest common factor out of all the terms. You have 3 terms, so this becomes an MAF problem. So we turn good old MAF. To get the M, you multiply the first and the last terms together. That's 72. The A is just the middle term. So we need 2 numbers that multiply to 72 and add to negative 17. What's that going to be? See who remember how to do that with numbers. We need 2 numbers that multiply to 72 and add up to negative 17. Like a Jeopardy music in a second. It is negative 8 and negative 9. I'll say it's okay for y'all to get it wrong. I mean, right now we practice it together. What's the worst thing that can happen? So we have our 2 numbers. Negative 8 times negative 9 is positive 72. Negative 8 plus negative 9 is negative 17. Remember, whatever your first number was, you have to divide by it. But dividing by 1 doesn't change anything. So again, for some of you, let it serve notice. You got to review factoring. Do it. Because you're going to be factoring a lot between now and the end of the school year. So if you need to review factoring, this is your warning now. Start reviewing it. This is solve. Set each part equal to 0. So m is equal to 8. M is equal to 9. There's your 2 answers. Questions, example 3. Alright, I'm going to at least get through the start of example 4. Before I post the notes, I will finish example 4 along with examples 5 and 6. So when I post the notes, examples 5 and 6 will already be done. So make sure you check out those notes. So example 4, 3x squared plus 13x equals 3x plus 8. This is another problem in which the equation is not equal to 0. That means you need to get it that way. So you would subtract 3x and you would subtract 8. You subtract 3x on both sides, 13x minus 3x would give you 10x. If you subtract 8 on the other side, you just have minus 8. There's nothing else to go with. This is still an MAF problem though. You have 3 terms. So you have to find 2 numbers that multiply to negative 24 and add up to positive 10. There's only 2 numbers that are going to work. Positive 12 and negative 2. But starting with a 3, so you got to divide by 3. You always divide by your leading coefficient. Always divide by your leading coefficient. Six times negative 4 is negative 24, but 6 plus negative 4 is 2. So it has to do both. So you have your factors, so that's x plus 4 and x minus 2/3 equals 0. You don't leave the fraction. So there's your factored form. Once it's factored, split it apart. That gives you x equals negative 4 and x equals 2/3. So with our last 2 examples, notice that there's a little bit different of a setup. Yes, the equation is not equal to 0, so we're going to have to take care of that. But in addition to that, you have 2 binomials. So when you are solving by factoring, and the fact that both binomials are different from each other, then we're going to have to multiply them out. Now, this is different from square roots in this fashion. If both of the binomials were the same, for example, x plus 7 and x plus 7 equals 84, then we could write it as x plus 7 squared, and then take the square root. So that's if both of the binomials were the same. However, these are not the same, so we got to find another way around. So the first thing that we need to do is to multiply the left-hand side. Multiply the left-hand side, so that gives you x squared plus X times 2 is 2x, 7 times x is 7x, so 9x plus 14 equals 84. But now that gives us the problem in which we got to get it equal to 0, which that part takes care of itself. Subtract 84 on both sides. X squared plus 9x minus 70 equals 0. We've got 3 terms. Now we solve it out. 3 terms is MAF, so we need 2 numbers that multiply to negative 70 and add to positive 9. That would give us positive 14 and a negative 5 as the 2 numbers that we work. The leading coefficient is 1, but if we divide by 1, that doesn't change anything. So you have x plus 14 and x minus 5 equals 0. Separate it into your 2 equations. So x equals negative 14 and x equals 5. And that's it for example 5. So notice in this case we had to do FOIL first to multiply everything out. Then get the equation equal to 0 before we can finally solve it out. So last but not least, example 6. 3x minus 2 and 3x plus 2 equals 45. So same rules apply. We have to do FOIL to the left-hand side. 3x times 3x is 9x squared. 3x times 2 is 6x. Negative 2 times 3x is negative 6x. So that, in this case, is 0. So that drops out entirely. Negative 2 times 2, negative 4. So you have 9x minus 4 equals 45. Now, check this problem out. There's no middle term in this problem. So this actually opens up 2 different ways that you can solve this problem. So I'm going to show you both ways. The first way, if we were to continue with factoring it, 9x squared minus 4 equals 45. Of course, you need it equal to 0. Subtract 45 to the other side. 9x squared minus 49 equals 0. So in terms of factoring, there is no greatest common factor, but the 9, the x squared, and the 49 are all perfect squares. So this is a difference of 2 squares problem. So remember, don't forget difference of 2 squares. So that's 3x plus 7, 3x minus 7 equals 0. So you can separate your 2 problems. So x equals negative 7 over 3. X equals positive 7. So that's your solving if you're going about factoring. However, since that middle term dropped out, you can also solve this equation using square roots. So you get a bonus method for this problem. So, if you're going to solve by square roots, then you would add 4 to both sides. 9x squared equals 49. Divide by 9, so x squared equals 49 over 9. Then you take the square root. So that leaves you x equals plus or minus 7 over 3, which is pretty much the same as negative 7 over 3 positive 7 over 3. So either way it goes, you're going to get the same answer with that particular problem. Although that problem allows you to solve it two different ways. It's not going to work for every problem. Don't think it's going to work for every problem. You have to really look at what you have and then go about solving it. So with that takes us through solving by square roots and solving by factoring. When we pick this back up, we're going to look at some of the applications that go with solving quadratics by factoring, which does bring back a couple of the forms that we've already learned in class. More specifically, intercept. With that, have a great rest of your day and ask questions as you have them.